All right, so the last example is y equals 3x squared minus 6x plus 1. Right, so this is our parent function, right? We're comparing everything to the parent function. Now with this one, it's a little different than any of the ones we've done before because this one has a b value. Everything else I've given you today, like 3x squared, 1/2 x squared, 1/3 x squared plus 3, there was no, linear number, right? There was no middle term here. There was no b value. So this is a little bit different. You can't really just get an idea of what's going to happen to it fully with this being the case. Right now it is going to be opening up because the a value is bigger than, or is positive. It is going to be vertically stretched because the a value is bigger than 1, but you can't really get a feel for like where it's going to be necessarily when there's a b value here. It's a little trickier. So we're going to have to kind of go through that whole negative b over 2a, right, which is always going to give me the vertex. You have to make sure you include that in your graph. If you're going to graph a quadratic, it has to have the vertex. And this is going to be the x-coordinate of my vertex. So when I do negative b over 2a, right, b is equal to negative 6. So if I did negative b, that would be positive 6 over 2 times a, and a is 3. So it's going to be 6 over 6, which is equal to 1. So that's the x-coordinate of my vertex. I'm going to put that in there. And then to find the y-coordinate, I simply just plug it in. So when I plug it in, I'm going to get 3 times 1 squared, which is still 3, minus 6 times 1, which is 6, plus 1. So 3 minus 6 is negative 3, plus 1 is going to be negative 2, right? So 1, negative 2 is the vertex of the graph. If I was told to graph it, I'd probably want to find another point. So if I know my vertex is right there at negative 1, or positive 1, like pick numbers around there. Like I'm going to pick 0 because it's super easy to work with. So when I plug in 0 for x, I'm just going to go ahead and look at, again, looking at the original. When I plug in 0, I get 3 times 0 squared minus 6 times 0 plus 1. It's just going to give me 1, which is nice and easy for me. So 0, 1. And without actually plugging in another number for now, I get another point, right? So remember, I have an axis of symmetry which goes through the vertex. So because I already know the vertex, I can use this axis of symmetry and say, all right, well, this point right here can be reflected over the axis of symmetry if it's really symmetrical, and it spits out another point on the other side of it, right? So I also get 2, 1 because I get 0, 1, and that's on the other side. Now, if you wanted to go ahead and plug in 2 just to show, 3 times 2 squared is 12, minus 6 times 2 is 12, so 12 minus 12 plus 1, it's going to give me 1, but that's not coincidence. That's because it mathematically works in it because of the axis of symmetry. Right, and so at this point, I can just plug in one more point. Like I'm going to plug in 3. 3 is not terribly difficult to work with. So again, if I plug in 3 into this x and this x, 3 squared is 9. So 3 times 9 is 27, minus 6 times 3. So 27 minus 18 is going to give me 9, and 9 plus 1 is 10. So I get 3, 10. And again, using this axis of symmetry, that's also going to give me negative 110 because I basically just bounced to the other side of that line. And so you see, we do have a graph that opens up, which we should have known before we started because it was a positive a value. And we have a graph that is definitely vertically stretched also because of the value of 3, right? But you can't really get much more than that without doing negative b over 2a.